Within this century, global warming will give us another ice age. No doubt you've been paying attention to it as well. Ireland is located at roughly the same latitude as Labrador, Canada, but generally has higher temperatures thanks to an ocean current that transports relatively warm water from the Gulf of Mexico to northern Europe. This is the Gulf Stream, one of the natural phenomena that most influences the Earth's climate. For over 50 years, climatologists have been studying its functioning to understand if and when global warming might block it, thereby disrupting the climate of much of the world. Now, research published in the journal Science Advances has added several relevant elements to what we know about the subject. Climate change in the Gulf Stream are linked due to the melting of ice in Greenland and other Arctic territories, which is caused by rising average temperatures. The more the ice melts, the more freshwater ends up in the northern Atlantic Ocean. This alters the dynamics of ocean currents, which are regulated by differences in water temperature and salinity, and could do so to the point of blocking the Gulf Stream. We still don't know when this might happen, but the new study confirms that the planet is approaching this situation. It states that there is a good chance the process of blocking the current could be triggered this century, and that the associated risks have so far been underestimated. Recent studies indicate that the outflow of cold water from the northern Atlantic has decreased by 20% since 1950, and northern waters have become progressively less saline. Unfortunately, these changes will not only affect Europe. Atlantic currents are just one part of a system that governs the climate across the entire planet. Slowing them down or altering their course could lead to dramatic changes in North America as well. It seems counterintuitive, but if the ongoing global warming hinders the currents by diluting their saline content, things could soon become very cold in those parts. If you remember the harsh winters of the late 70s and early 80s, you might also recall at that time there was much discussion in scientific circles about whether the frigid weather conditions were a harbinger of a new ice age. In recent decades, such warnings have been overshadowed by the great debate on global warming and considerations of how society might cope with a sweltering planet rather than a frozen one. Apparently, the fact that we are still in an interglacial period, during which ice related to its polar strongholds only a few thousand years ago, seems to have been forgotten, perhaps relying on the idea that global warming might prove useful in at least one thing: keeping the threat of a returning ice age at bay. But is this really true? Is it possible that the rapidly accelerating temperature increase we are experiencing could actually hasten the onset of a new ice age? Alas, yes. A growing body of evidence suggests that, at least for the UK and Western Europe, there is a serious risk that this could happen, and soon. The problem, as you might have guessed, lies with the ocean current known as the Gulf Stream, which bathes the UK and northwestern Europe with warm water transported north from the Caribbean. It is the Gulf Stream and its associated currents that allow strawberries to thrive along the Norwegian coast, while at comparable latitudes in Greenland, glaciers extend down to sea level. These same currents enable palm trees to flourish in Cornwall and Hebrides, while across the ocean in Labrador, even the hardiest and most unproductive vegetation struggles to survive. Without the Gulf Stream, temperatures in the UK and northwestern Europe would be about 5 degrees Celsius or 9 degrees Fahrenheit cooler, with winters as harsh as those of the so-called Little Ice Age in the 17th to 19th centuries. So all is well, right? Not quite. The suspicion that something might go wrong arises when we examine in detail the mechanism that fuels the continuous and beneficial circulation of this warm water flow. Okay, bear with me. The ocean's water is constantly circulated by currents. Tidal currents occur close to shore and are influenced by the sun and moon. Surface currents are influenced by the wind. However, other much slower currents that occur from the surface to the seafloor are driven by changes in the saltiness and ocean temperature, a process called thermohaline circulation. These currents are carried in a large global conveyor belt, which includes the AMOC, which stands for the Atlantic Meridional Overturning Circulation. The Yamok circulates water from north to south and back in a long cycle within the Atlantic Ocean. This circulation brings warmth to various parts of the globe and also carries nutrients necessary to sustain ocean life. The circulation process begins as warm water near the surface moves towards the poles, such as the Gulf Stream in the North Atlantic, where it cools and forms sea ice. As this ice forms, salt is left behind in the ocean water. Due to the large amount of salt in the water, it becomes denser, sinks down, and is carried southwards in the depths below. Eventually, the water gets pulled back up towards the surface and warms up in a process called upwelling, completing the cycle. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. The entire circulation cycle of the Yamok and the global conveyor belt is quite slow. It takes an estimated 1,000 years for a parcel, any given cubic meter of water, to complete its journey along the belt. So you get it. In simple terms, this is the process that has kept the climate of Northern Europe temperate and relatively stable for the past 10,000 years. But has it always been this way? No, unfortunately. We now have solid evidence that about 13,000 years ago, the Gulf Stream experienced a significant slowdown, plunging all of Northern Europe into a period of glacial cold known today as the Younger Dryas. During that time, the current weakened severely, causing temperatures in Northern Europe to drop by as much as 10 degrees Celsius or 18 degrees Fahrenheit. As a result, most of the UK was reduced to a desolate frozen wasteland for a period of at least 1,300 years. This climatic anomaly was named after a charming white flower from the Rosaceae family, characteristic of the tundra, the Dryas octoptatala. It was the study of the disappearance of its pollen, verified through ice core samples, that indicated something very unusual must have happened in those regions 13,000 years ago. The sudden reappearance of a new glacial period, when the Earth was already emerging from the last ice age, must have had disastrous consequences for the entire animal world, not just humans. For example, the climate in Siberia before the cataclysm was quite mild and certainly much warmer than it is today, with extensive grasslands and forest where large animals like mammoths, woolly rhinos, cave lions, saber-toothed tigers, and many other species lived. But all these creatures suddenly disappeared. Identifying the exact culprit of this dramatic extinction is incredibly complicated. There are several suspects and the evidence is substantial, but the final verdict is still far off. Until about 10 years ago, the theory of a cosmic impact in the form of a comet nucleus disintegrating in the atmosphere was very popular. Although this hypothesis had the merit of also explaining the simultaneous disappearance of megafauna in North America, it was heavily criticized and then replaced by a much more terrestrial one. Over the years, the idea that gained more and more acceptance was that the Younger Dryas was triggered by an abnormal ocean circulation caused by the influx of colder, less salty water from the melting ice deposits accumulated during the just-ended glaciation. Starting in the 1960s with the studies of American oceanographer Henry Stommel, it was hypothesized that an extensive increase in the amount of fresh water from the rivers and glaciers of North America and Greenland could block the Yamok. The reason is that water from the continents dilutes the salty ocean water. In the specific case of the North Atlantic, continental waters dilute those of the Gulf Stream. The hypothesis about the Yamok blockage is that if they do so extensively, it would decrease the density difference that drives warm water from the Gulf of Mexico to Northern Europe. This hypothesis also suggests that this mechanism imposes the presence of a sort of tipping point, a critical threshold beyond which a system is disrupted, often abruptly or irreversibly, or both. An expression that could be interpreted, at worst, as a point of no return. But why should we fear that something similar to the Younger Dryas could happen again soon? Well, the reason is that in addition to all the other potential change factors, we are now dealing with global warming, which is causing the Arctic and Greenland ice to melt too much and too quickly, pouring fresh water into the ocean and thus diluting the salinity of the waters in the North Atlantic. This decrease in salinity makes the water less dense and less likely to sink as it moves south after reaching Greenland, skirting America. Less sinking of cold water causes less push of warm water northward, with the consequence that the Gulf Stream has been slowing down for decades. And this, folks, is not a prediction that could turn out to be wrong, but an absolutely observed fact. Previous studies based on ocean surface temperatures have shown that the Gulf Stream has already slowed by 20% since 1950 and is now at its weakest in over a millennium. This threat has been known for some time, but scientists are now outlining it with more precise details. In 2023, a study conducted by the Institute of Mathematical Sciences in Copenhagen suggested that the system could collapse between 2025 and 2095 with a 95% confidence interval. You heard that right. This terrible event could happen by 2025, not in the distant future. The various scenarios proposed by cutting-edge computational models see Central, Northern Europe, and the Arctic as the epicenter of the potential climate shock. In Europe, we would face extremely cold winters just a few years after the Gulf Stream's interruption, especially in Scandinavia and the UK. Here, temperatures could drop by 3 degrees Celsius or 5.4 degrees Fahrenheit per decade, while some parts of Norway could experience temperature drops exceeding 20 degrees Celsius or 36 degrees Fahrenheit. Precipitation would decrease considerably due to the reduced heat and water vapor supply, and the Arctic ice sheet would extend much further south. These sudden and intolerable changes would cause the collapse of current marine and terrestrial ecosystems, leading to a massive economic and social crisis on a continental scale. But Europe wouldn't be the only region affected. The Atlantic Ocean level would rise by 70 centimeters or 27.6 inches, submerging numerous coastal cities in the USA as well. Rainfall in the Amazon rainforest would drastically change, turning it into a grassland, and the southern hemisphere would become increasingly hotter. Overall, there remain many uncertainties about the impact such an event would have on a planet undergoing another equally marked and rapid change, but in the opposite direction. Moreover, the areas that would suffer the most severe effects, the Arctic and Europe, are also two hotspots of current global warming and ongoing climate change, making simulations even more difficult. There is no doubt, however, that we are talking about an event, the collapse of the Atlantic thermohaline circulation, that we must absolutely avoid, as the consequences would be extremely negative, according to all publications on the subject. To do this, we must work on a rapid and drastic reduction of greenhouse gas emissions into the atmosphere, particularly CO2. But at this point, who can assure us that every move we make in an attempt to manipulate the climate won't backfire, leading us into an uncontrollable spiral of action-reaction? Once again, this highlights the fact that global warming, for which we have only ourselves to thank, is nothing more than a grand planetary experiment, many of whose outcomes we cannot predict. Wallace Broecker, a researcher of ocean circulation at the Lamont Doherty Earth Observatory in New York, perfectly described the situation when he emphasized that the climate is an angry beast and we are poking it with sticks. Let's hope that when it finally turns against us, its teeth won't match its indignation.